Okay, investigation 19.1, waves in motion. This is another great lab to get the students interacting with materials and really seeing how things move, especially in the terms of waves. I did check, it kind of comes across on video this year, but I think you all know what ripples look like. So if it doesn't come in clear enough, just set up your own tray and you'll see everything that I'm talking about. But actually, you first start off with the springs for the demonstration. Now what you'll find with springs is these are the first piece of equipment that get broken. So if you got one of those skinnier and longer springs, you might want to break those out because those make good waves as well. This one's also pretty good for viewing the wave. And so the instructions have the students, it says grab 2 students and they spread the slinky about, I think it says 3 meters apart. I'm not gonna be able to do that just by myself. But you want one person to hold perfectly still. So this hand here, I'm gonna hold perfectly still. And this one, I'm gonna try to go up and down just once. And if you pause, you should be able to see just one wave move across. So here's what that looks like. You can see that wave move across, bouncing back. And as long as I'm not continually going, students can see a wave propagate. Students should observe that as I do the wave going to the left, the wave is up that way, but when it bounces off, the wave flips and goes the other way. So go ahead and watch. You can see it flips the direction that it goes. So it asks the students to answer some questions about that. How does wave movement differ from normal movement, like for a car? And then it asks about doing longitudinal. So that was latitudinal, and now longitudinal wave pulses, you're actually gonna have one person move their hand in and out really fast. So this is what that looks like. You can see a wave pulse move through the springs. And if you can time it up, you can keep that wave going. So that might actually open up a good discussion with students about AM, FM radio. I believe that's the main difference between the two. One is longitudinal, one is, because it's frequency modulated and amplitude modulated radio. And I believe they work off those 2 principles there. So that might be done as a demonstration if you have a good overhead camera, or have students do it in the middle of the room, or you can have the slinkies at each station and students can experience it. Totally up to you. If you get these guys out, they're probably gonna get broken, or have a discussion about students about not pulling these too hard or else they do break. All right, then after you get through the slinky demonstration or part of the lab, you get to the wave tray. And the wave tray has a few demonstrations. One of them is just kind of doing the standard ripple effect. So do one touch in the middle, you should see the ripples propagate from the inside out. Next, you should be able to generate a somewhat parallel straight line wave by just moving this guy a little bit. And if you can move it right, then you shouldn't get interference, but me pulling back causes issues. Problem with this demonstration is you do have to wait for it to reset. So I'll do one more. And there, if I didn't go back, you can see one wave propagating forward. It's like a plane wave. It really is the same as the ripple effect, except I've created it all at one time and there's nowhere outside of it to go. So it looks just like a wave. And you can have a discussion with your students that this is similar to how light waves come to Earth. It's so far away that it might as well be parallel lines coming and reaching us. And then the last one, and this comes in handy for a discussion later about the property of waves and specifically light. So if I set up these 2 metal blocks so that there's a gap here in the middle, when I do the wave, this blocks the majority of the wave coming through. Don't do it too hard. And what they should see is now you get that propagated circle wave coming from that entrance. Let me go ahead and fix that. So I'll do a little wave, and I see it propagating as a circle coming off from there. And so students will understand, okay, so a wave will hit a corner and it goes around the corners. And that's a property of waves. And so when you get to the dual nature of light, there's the slit experiment and the double slit experiment that students do with light waves. And you can call back to this or even bring this back out. I mean, it's a pretty easy setup. Whoop, making a mess. And that would be a good way to discuss the dual nature of light. All right, I'm gonna clean up my mess and I'll see you guys at 19.2.
Pardon the interruption.